Okay, we left off with the first line of defense. Lance, what is our first line of defense? Our skin. Does your skin care what it encounters? No, just as long as it stays out. If it doesn't care, is that going to be considered specific defense or non-specific defense? Non-specific. Your skin doesn't care what it comes in contact with. It just cares that it stays out. There's another component of your first line of defense that is not just your skin. Do any of you recall what the other one is, Kylie? Your mucous membranes. Those are the membranes of cavities that lead to the outside of your body. Your mouth, your nose, urethra, vagina, and anus. Those lead to the outside. Your ears and your eyes don't count because those do not go directly to the inside of your body. Look at your own skull anatomy. Though your ear holes and your eye holes do not go all the way to your brain. Nerves do. So what if what that first line fails? Your skin is cut open. What happens? You have a second and third line of defense. We're going to get to the second line today, and we'll probably have to finish it tomorrow for the next video. So today we're going to do innate internal defenses. This is your second line of defense. Innate external defenses was your first line. So this kicks into action, or the second line of defense is non-specific. This means it doesn't care. It does not care what the pathogen is. The point is the pathogen is in the building. It's got to go. It must leave. If you ever caught a speed trap on Bayshore Boulevard, the police officers don't care who you are. They don't care what you're driving. They care that you're violating the law. They're not going to say, oh, there's Emma. Let's get her. It's not what's happening. They're going to say, oh, there's a speeder. I don't care what their name is. They have to be stopped. If you have pathogens that enter your body, you do have a second line of non-specific defense. They include phagocytes. Phagocytes are cells that actually, for lack of a better word, gobble up and eat pathogens. The proper term is phagocytosis. You have natural killer cells. These cells do not phagocytize. What they'll basically do is they will touch a cell and the cell will die. It's like the touch of death. Next, you have the inflammatory response. And finally, we have complement proteins. These four components of your second line of defense don't care if you're a bacteria or a virus or a protozoan or a parasite or what type of parasite or bacteria or so on. They care that you're in the body and you can't be in the body, and they need to help get rid of you. So we are going to start with phagocytes first. Phagocytes have a couple other names. They're also called leukocytes. And what color cells are leukocytes? These are also known as white cells or white blood cells. They perform a process known as phagocytosis. Phagocyte means eater, cell, and phagocytosis means cell eating process. There's an old video game that's way before your time called Pac-Man. You ever heard of it? I know it's old, but a lot of people have heard of it. Basically, in Pac-Man, It just goes along and gobbles up. That's what phagocytes do. You what? Nah. All right, so we are going to go over the 6 type of phagocytes. Can you get that, Kylie? Just say Mr. Thorson's class. So types of phagocytes. Here she is. Okay. First ones are called basophils. A basophil targets bacteria and parasites. And they release histamine and heparin. Now I get the drawing. Let's see. How do we want it to look? That's a basophil, Katie. Kate.
So that we draw.
Yeah, Emma. Do any of you have allergies? No one in this classroom has allergies. What do you have allergies, Lance? Pollen. Boy, you love this time of year. What happens when you come in contact with pollen? Do you swell up at all? No? Anybody, what other allergies? Do you swell? Anybody else? Kylie? What? Oh, kiwis. What happens if you eat a kiwi? Swells up. Okay, Emma? Pineapple. What happens if you eat pineapple or drink pineapple? Is it? Caitlin? What happens when you have ibuprofen? Hives. Okay. A lot of you mentioned swelling. Well, that is what histamine does. So histamine induces swelling. But swelling is such a rookie term. So I want to have you guys use the proper term. I'm going to kind of X out swelling. We're going to replace swelling with vasodilation. Vasodilation is a much better word than swelling. Swelling is basic. Vasodilation. This means blood vessels enlarge. Their diameter enlarges. This is what causes the swelling in your tongue or in your face or your whole body when you're having an allergic reaction or when you are encountering an inflammatory response. Later today, I'll tell you why you release histamine in the first place. But just for now, know that histamine does cause swelling. Now, for those of you that do have your allergic reactions, and if you start to swell, what are some things you can do to alleviate your swelling? Kylie, if you bite into a kiwi and your tongue blows up, what do you do? What do you do to cause the swelling to go down? Okay. Anybody else? Amara, do you take anything? You go inside. There is a topical, or not a topical, there's an over-the-counter treatment for people that are experiencing swelling of either from an injury or an allergy. It's called Benadryl. Do you know what is in Benadryl that causes a reduction in swelling? An antihistamine. Antihistamines will counteract the effect of histamines and hopefully reduce your swelling. Heparin is a blood thinner. Both of these are going to be trying to accomplish the task of allowing white blood cells to get to the area of infection so that the infection can be fought. When you all are driving your cars, what are you supposed to do when you hear sirens or horns blowing behind you? Pull over. Why are you trying to pull over? Get out of the way for what? The emergency vehicle. You need to increase their pathway. You need to make their pathway unobstructed. That is why your blood vessels swell and you have blood thinner during an infection, is because the white blood cells need a clear path to get to the site of infection. So everything needs to get out of the way. And also when your blood vessels are swelling, that allows for more white blood cells to go to the area. Imagine if Dale Mabry could double in size when there's a car accident. Way more cops, way more ambulances, way more police can come and actually get to the site where there's been a crime or an injury or an accident. Okay, next one. All you future nurses out here, this is a good one for an answer to a trivia question. Neutrophils. A neutrophil is the most abundant white blood cell in the body. They target bacteria and fungus. They respond and multiply quickly. Here's their downside. Their phagocytosis has limits. That means that they do have the ability to get quote unquote full. They can gobble up a few bacteria and then they're done. That's why they need to replicate and replicate and replicate to make more and more and more and more and more and more and more. But these are the most common white blood cells in your body. And you might be the most abundant, by the way. You might be wondering, what are all those projections that are coming off of that cell? What those projections are is that they're able to grab bacteria and kind of bring them back into the cell. So it's like, grab you, I'm going to grab you, I'm going to get this, I'm going to get that, and you bring it back inside, you just gobble them up. That's what those are for. And I actually have an image of this from second period. There it is. Those extensions are grabbing bacteria. The bacteria are the green things. And this neutrophil is grabbing them and it's going to bring them back into the cell and phagocytize them, which is disintegrating them, eating them alive. Okay, next we have eosinophils.
Is this what the 6 colors are for?
Yeah,
Oh, fun.
isn't it? Eosinophils target parasites. Now, I have a question for you guys. Have you ever seen the movie called The Meg? About the giant shark? How did they kill the Meg in the movie? Anybody remember? No, that's Jaws. Everybody keeps saying they blew it up. That's Jaws.
No,
Yeah.
they did.
No.
And then
No.
they tried to find a bigger one, didn't they?
They did find a bigger one, and the bigger one ate the smaller one.
That's the last one. But then what do you do with the giant one?
How did he die? No one remembers. Here's how they did it. They cut this big bloody gash along the belly of the shark to get it to bleed. And then what did all that blood attract? Oh, all the normal size sharks come and they just basically eat it from front to back. They just cover it. Well, that's kind of how this goes. A parasite is massive. Worms. Do you need a microscope to see a parasite? No. Do you need a microscope to see an eosinophil? Yeah. So let's say that you have a worm such as this. You don't need to draw this. And a eosinophil is like that. You can't even see that. Look at that. There it is. That's an eosinophil. How is that supposed to destroy that worm? Numbers, Sebastian. What do you mean? A lot of them. So this worm is just going to have to be covered in eosinophils to try to slow it down. Just like all those sharks all over the Meg, or like a bunch of army ants all over a rat. What? What do you mean it produces more? The bacteria? Eosinophil is not a bacteria. No. Caitlin, that's not what you're.
Okay, I want to say the thing.
The thing? No, you're not. You're right. I don't understand because you say thing and you say the wrong thing. The phagocyte. Use the right terms. That's all I ask. Now, this is not a guarantee that the eosinophils can stop the worm. You guys heard the story I told you the other day where this guy had a 32-foot long tapeworm in his body. That apparently was able to survive. So these things are, these eosinophils are, it's just like anything in life. They're not foolproof. They're not guaranteed to work. All right. And then we get to the last group, monocytes. A monocyte is not fully mature. He's so cute. They mature in the lymph nodes. And they can actually mature into 2 different types of cells. Give you guys a moment to catch up, then I'll tell you what they can mature into. All right, they can become a macrophage. If phage means eat, what does macro mean? Big. This literally translates into big eater. This is the big boy. What? All right. This macrophage does something that the neutrophils don't do. They don't get full. A neutrophil can phagocytize a few bacteria and then they're done. They die. Macrophages can eat and eat and eat and eat. Macrophages break down microbes, which are bacteria. And I want to show you guys a video of a few macrophages actually in action. So I'm going to pause the video for a moment.